Hello students, for today's session, we will be learning the seventh program in your AI lab, that is using any standard data set, write the programs for the following machine learning task, that is use the decision tree classifier to classify the data set, that is you have to download a standard data set and then do the use the decision tree classifier, that is inbuilt function you will be using to train the model and then check the accuracy of the model, the data set you are going to train, split and then find the accuracy of the model. So for this, in our program, we are using the uh, file called diabetes.csv. Diabetes.csv, I had downloaded it online from GitHub. This is the file diabetes. You have to download the file diabetes.csv, that is a comma separated value file it is, and the file, that is a Python file in which you are writing your program, that has to be stored in the same folder. This diabetes.csv file and your Python file should be present in the same folder. Then only you can execute the program. I'll let you know how was it. Before that, let us see what is decision tree. Uh, Decision tree is nothing but it is a supervised learning technique which can be used for both classification and regression problems. That is classification, the categorizing yes or no kind of problems, and the numeric problems we use. But mainly we use it for classification problems. So how it works in decision tree? The classification of data is in the form of a tree. It forms a tree structure, classifying it into a tree structure as shown in this diagram. In this decision tree algorithm, we break down a data set into smaller subsets, while during the same time we are forming an associated decision tree incrementally developed like this. You have the decision node, that is root node, and then sub branches decision node, and then forming onto the leaves. This is an example showing the decision tree. Now we will directly move on to the program for implementing the decision tree in Python. Here is your program which uses the diabetes.csv file. The initial code, you can see this is the initial code where you are going to use the Python libraries, that is the pandas library, sklearn. From sklearn.tree you are using importing the decision tree classifier module, this function, inbuilt function, you are importing it. And from sklearn.model library, model selection library, you are importing the train test split. This inbuilt function will this one, what to split the training data and the testing data from the data set. And then from sklearn you are importing the metrics module. So these are the Python libraries that you are importing it into your program in order to use the decision tree classifier. Now what you are doing is column names is equal to, from the diabetes.csv you are choosing what and all column names you want. That is, I'll show you where I have stored the diabetes.csv in the desktop under the folder named program 7. I have downloaded and kept this diabetes.csv. I will upload this file as well when in the Google Classroom. So if you open this diabetes.csv, you can see a number of columns here, that is pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, and so on. So this is your CSV file. Now going back to the program, here you are specifying the column names in the first line of your code. You are specifying the column names, that is glucose, pregnant, glucose, BP, skin, insulin, BMI, pedigree, age, and label. So these are the column names. You are specifying it manually. And then your next line, what you're doing is using this pandas library as PD. You have an object here as PD. So PD dot, how to read the CSV file. This is how you read the CSV file into the program. PD dot read underscore CSV. This is a keyword. Okay, PD dot read underscore CSV of, you have to specify the file name, that is diabetes dot CSV. Header you are initializing as a 0, you're not giving any headers, and names you are using the column names. This column names you are using, and then you are storing it into the object called DS. You are creating the object for this diabetes.csv file. Now we will just print this DS, what the data is. You can see the data when you print this DS variable. Print DS, this will give you this output, the data along with the column names. See, column names: pregnant, glucose, BP, skin, insulin, BMI, pedigree, age, label. These are the column names, and these are the datas it has read. So how many datas it has read? 768 rows, and it consists of 9 columns. See, dot means a number of datas are there in between. Okay, so this is the total number of rows and columns it has read from that particular diabetes.csv file. Next, this this data set, you call it as diabetes.csv, is nothing but your data set. This you are going to split into features and label. That is, features are nothing but from which features you want to predict the label. That is, these are the features: pregnant, glucose, BP, skin, insulin, BMI, pedigree, and age. These are the features. Using these features, you can predict the label. Label is nothing but 1 means the patient has diabetes, 0 means the patient does not have diabetes, 1 means it has the patient has diabetes and does not have diabetes, and so on. Label data is also given here. Now here what you are doing, feature underscore columns. So in order to predict the label, what are the features required? Only those features we will consider. That is, you need pregnant information, insulin, BMI, age, glucose, BP, and pedigree. So these are the columns which will use for predicting the label. So, that means from the original data, you are excluding some columns. That is, skin you are excluding, then what else? Glucose you are excluding, BP you are excluding. All these are you are excluding, and you are keeping it precise. Only these feature columns we will use for prediction. This you are using, and then that features, DS of feature columns, you are putting it into X, and the label, ds dot label, this label from here, this label you are putting it into the variable Y. Next, what you are doing is you have to split the data set into training data set and testing data set. It is like a training data set is for the model to learn to predict, and testing data set is to check how accurately a particular model is doing the prediction. Okay, so for example, if you consider your data set is 100% data set, out of that usually either you will keep 70 or 80% for training and 20 to 30% for testing the data. That's how you split the data set in machine learning. Accordingly, how much data set you are using, the more the data set you are using for training, the more accurate the model will be. Now, okay, you have assigned the x and y values. Next, what you are doing, you are going to split the data set into training set and test set. This is done by the inbuilt function called train test split off. This is imported from the Python module sklearn model underscore selection. So here what you're doing, x underscore train comma, these are variables, x underscore test comma, y underscore train, y underscore test is equal to train test split off. You're specifying x and y, and then the test size you have to specify. Test size you are specifying here as 0.3. That means 0.3%, that is 30%, will be considered as testing data set, and the rest 70% will be considered as the training data set. For training it will be allotted. So this train test split is done using this inbuilt function train test split. And then you have a random state specified as 1, that is nothing but for repetitions we use this random state. Initialize decision tree classifier object. Now you have to develop a model using the decision tree classifier. So for this decision tree classifier, which is also an inbuilt module which comes under, see here, decision tree classifier, we have imported it from the Python library sklearn.tree. Directly you are importing the decision tree classifier, and for this decision tree classifier you are initializing an object by name CLF. So using this object you can call this decision tree classifier. Now next what you are going to do, you are going to train the decision tree classifier with the data set. So what for that, what you have to do, the object name dot fit of x train comma y train. So the data that data set, that is the 70% data set which you have allotted for training here, the 70%, this is for test size, this is the train test size. So for training it is 70%. So that 70% you are using it for the decision tree classifier to learn to predict the model. Next, yeah, and then you are assigning it into the object, that is CLF. Next what you are doing is predict the response for test data set. You are predicting the test data set response, that is CLF dot predict off. Predict off, again it is an inbuilt function which will predict the X test data set, and then you are storing the test data set into Y underscore predict. Next thing what you have to do is you are calculating the accuracy of the model, this model which you have developed. So using the decision tree classifier, in order to calculate the accuracy, you have inbuilt function, that is accuracy under score, metrics dot accuracy underscore. Again this metrics you are importing it from the Python library sklearn. It is inbuilt function, directly you can use it. So here what you are doing, inside this you are giving two parameters. One is the y underscore test, that is in the testing data set, what is the label values. Original label values will be there in the y underscore test, and in the training next is the predicted values. Using the model, what is the predicted values, label values, y underscore pred. So this is your predicted y label values. Considering these two, it will check what is the accuracy of your model, and you are going to print the accuracy value. Now in the output you can see it has printed the accuracy value. Accuracy is equal to 0.6753 something. That means it has 67% accuracy. The model is 67% accurate. Now 67% means it is normally it is considered as a good model. This is your program, and so this is your program code, and this is your output here. Now one thing you have to keep in mind how to execute this program. I'll tell you. Once if you use, that is in the after you open the Spider IDE, once if you type your program, you have to type all the lines of code. After typing the code, you have to save the file. Save the file as, save as. For example, say you are going to, you can just create one folder in your desktop like this by any name. Create a folder and you are going to store the Python file into this folder. So what you have to do in the this one Spider, go to file and click on save as, and then go to desktop and then select the folder where you want to store the file. Click on that and then give the name. I've already given it as tree. Give the name of the name of your program file, and then this save as type you have to change it to Python files. Select Python files and then click on save. Okay. So after clicking on save, it is giving a pop-up because I have already saved the program.